Hello everyone, welcome back. This is Mr. Osam, and in this video we'll be looking at vibrations and oscillations. Alright, so before we begin, don't forget to like and subscribe to the channel. Okay, so I'll try to explain this as simple as I can. So try to work with me. Alright, let's begin. So I want us first to understand the terms that are used under vibrations and oscillations. By beginning with the main terms that are attached to the topic. So let's talk about vibrations. Now, most of us understand that vibrations are just physical evidence of what? A wave. Any physical evidence that defines a wave is called what? A vibration. Now, on the other hand, we can think of vibrations to be rapid back and forth movements of physical particles as a reaction to, say, different forces. Now, you should bear in mind that vibrations could involve, let's say involves the disruption of something from its equilibrium point, that is a rest point. Now, this is simply just a balanced state between opposing forces. Now, vibration is just usually discussed in relations to most likely sound, but in this context, we're trying to relate to simple harmonic motion. Now, just food for thoughts, vibration can be free and forced. Now, if you're looking at free vibration, it's like the type of vibration in which, let's say, a force is applied to an object once and say it is allowed to vibrate at its own frequency. That is free vibration. Okay, a type of vibration in which a force is applied to an object once and it is allowed to vibrate at its own frequency. Let's not forget that. But if you look at forced vibration on the other hand is just a type of vibration in which a force is rapidly applied to an object to maintain the vibration. An example we can look at in terms of forced vibration, we can look at the one that is caused by the forces from the road, or this is springs and engines. But if we were to look at examples of free vibrations, we can look at things like maybe a guitar string being played. Yeah, but basic examples that we can highlight is simply just a weight dangling from the spring, that's free vibration. Shaking of a washing machine due to an imbalance. Alright, now that we understand what vibration is, let us now talk about what is called oscillation. Now, oscillation is one complete movement that is from the rest or say equilibrium position and back to the rest or equilibrium position. Now, in other words, I would say that oscillation is just defined as a process of repeating variations of any quantity or measure about its equilibrium value in a given period of time. I'm just saying in time to say. Now, others would also want to define oscillation to be, say, a periodic variation of a matter between two values or about its center value. Now, we need to also understand that oscillation can be mostly understood in terms of examples. But we'll look at the examples very soon. Alright, let's look at the next term. The next term is called the amplitude. Now, amplitude, this is the maximum displacement of an object. It's measured in meters. It's quite simple. So, amplitude is something that relates to maximum displacement of a wave, to be precise. But, if we want to visualize this clearly, I can give you roughly, let's say you have a wave like that. The highest point of a wave is termed to be what? The amplitude. So remember that the highest point of the wave is the amplitude. But we could just say the maximum displacement of an object. But in terms of a wave, don't forget the highest point. Alright, let's move on to the fourth term. Now, displacement. Displacement is just a distance from rest or equilibrium position. Now, you have to bear in mind that it can either be from the right or left side of rest or equilibrium position. Displacement, we know the units are meters. Okay, this one is a simple one. Let's move on to a different one. Periodic time. Now, just the same way we always define it. Periodic time is simply just time taken for one complete oscillation. So the formula is simply just time taken over the number of what? Oscillations. Then the units are simply just what? Seconds. Then we have frequency. Frequency is the number of oscillations produced in a given period of time. The formula is number of oscillations over the time taken and is measured in what? Hertz. Frequency can also be just equal to 1 over what? The periodic of oscillation. Alright. Let's talk about what we call oscillatory motion. Now, in simple terms, this is just motion that repeats itself. But in oscillatory motion, an object tends to repeat certain movements in, let's say, the same pattern repeatedly, okay, until it's acted upon by some, say, external force. Yeah. But the movement, when it comes to oscillatory motion, is simply just a to and fro, or let's just say back and forth, or just a vibratory in nature, to say. But again, one thing you should bear in mind is that in the absence of friction, the oscillatory motion has the ability to go on forever till eternity. This is something that is interesting. If we had to look at examples of this, we can look at things like before we even look at examples, let's bear in mind of something. A body in such a periodic oscillatory motion, or let's just say, oscillatory motion, will oscillate about the rest or equilibrium position due to the restoring force. Now, going back to the examples. Examples of oscillatory motion can be, say, things like a pendulum of a clock. Now, we need to understand clearly how this or why it is an example. Now, a pendulum clock is one of the perfect examples of oscillatory motion, to be frank. But this is just because the pendulum of a clock gets displaced from its original position and it returns back after covering a certain distance on both sides of the normal position. Now, that action is what we're calling the to and fro movement. Okay? Yes. And this to and fro movement of a pendulum bob goes on and on. Now, a pendulum clock, some of you I don't know if you visualize it, but it's those clocks that they are mostly you would notice them in movies. They're quite common. They move back and forth, especially in cartoons. You would see them in most cases. Okay, then we can look at the motion of a child on a swing. Now, when it comes to the motion of a child on a swing, you can just if you look at a swing, it's just like some prominent examples of oscillatory motion in real life, because initially when the swing is in the rest state, it is said to be in an equilibrium position. But when you push that swing, or when a push force is applied to the swing, to say, the equilibrium gets disrupted and the swing gets displaced in a direction of the force applied. Now, after covering a certain distance, it returns to the original position and it covers an equal distance in the opposite direction. Now, once that happens, then we can say it has exhibited what we're calling oscillatory motion. Now, I won't actually mention them all. It's just food for thoughts for you to understand how these things work. Then when it comes to a vibrating tuning fork, for this tuning fork, when a tuning fork to say is, let's say, when it is struck against a glass, it tends to vibrate rapidly. Now, the vibration of a tuning fork is yet another example of oscillatory motion, because the tines of the tuning fork move a particular distance on either side of the equilibrium position. That makes it to exhibit oscillatory motion. All right, I think we can also look at the last one, because atoms in solids, this one is just it's a no-brainer. Air molecules oscillating when sound travels through air. This one is just straight and direct. What of the beating of the heart? Now, if you look at our heartbeat, it beats. Okay, let's say it's heart. The beat is constant to say, and you could say rhythmic in nature. But when our heart pumps the blood in and out, it causes the heart muscles to move to and fro. Now, this motion of the muscles away from the normal position in opposite directions indicates the existence of oscillatory motion in the heart. I hope it's clear. Now, these are just some of the examples, but there are many examples of oscillatory motion. Alright, thanks for watching this video. If you have questions on vibrations and oscillations, you can reach me on WhatsApp on that number, or the number I'll put in my description. Alright, this is Mr. Hussein Wasabi. Don't forget to like and subscribe to the channel. Remember to study jazz before you become a statistic, and let's try and push for that A+.